Before you proceed with testing of a diode, you have to know that a diode is composed of a PN junction with P-type semiconductor on one side and N-type semiconductor on the other side. That is the PN junction. Then we have to know that when it is forward biased, there will be a depletion zone here where the current carriers will be minimal. And forward bias means P-type is anode that is connected to the positive pole of the battery, and cathode or the N-type is connected to the negative pole of the battery. This is the electronic symbol corresponding to the diode. Then this is the blown out picture of the diode. You can see that there is a ring at one end, or either a marker, which you can see here also, but this is a real diode. The marker is very tiny. If you are careful, you can see, or with when you see it directly, you can see very well. This is a rectifier diode, and this will be the cathode, and this will be the anode of the diode. So this basic information is needed. And when a diode is forward biased, these are silicon diodes. When silicon diodes are forward biased, there will be a voltage across, that is 0.7 volt. Usually for silicon diode it will be 0.7 volt, and for germanium diodes, which are seldom seen nowadays, it will be 0.3 volts. So this is what we are going to measure using a multimeter in the mode for diode testing mode. There is a selector switch which will select for diode testing. We have to know about the concept of peak inverse voltage, that is the maximum voltage which the diode will withstand in reverse bias condition. Usual diodes will withstand about 50 volt in reverse bias condition, but there are high voltage diodes also which can withstand very high voltages. So that is peak inverse voltage. When you apply an alternating current to the diode for rectification, you know that during one half of the alternating current, the diode will be forward biased, and during the other half of the alternating current cycle, it will be reverse biased. So that is where this peak inverse voltage comes in. If the peak inverse voltage is low and you are applying a higher voltage of alternating current to the diode, then it will break down. For testing a diode, you have to choose the selector switch in such a way that it indicates the diode symbol. That is how you test it. And then the black lead is connected to the cathode and the red lead is connected to the anode. Here I am using a yellow cable with crocodile clips on either sides to connect from the red lead to the anode, and you can see the display here 555, that is actually 0.555 volts or 555 millivolts, that is being shown here. Now we will reverse the connection and see. Now the connection of the diode has been reversed, and you can see that what is shown is 1. 1 in this multimeter means it is beyond the range. It is not measuring that. So that is because this is reverse biased now. When the diode is reverse biased, no current flows across the diode till it reaches the breakdown voltage or peak inverse voltage which we discussed in the beginning. Now I am testing another diode of the same type. You can see that there is slight difference in the voltage across the diode in forward bias condition. It is 538 millivolt rather than 555. This was the diode which we tested initially, and this is another diode. There is slight difference. Such variation can occur from device to device.